Well, good morning, good afternoon, good evening, good night, wherever you may be, somewhere in this world, whatever time zone you're joining us from. Thanks so much for being with us here today for Serverless Office Hours. We're live streaming on the AWS Twitch channel, on YouTube Serverless Land, and also via LinkedIn Live. My name's Julian Wood. I'm a developer advocate as part of the serverless team at AWS, and I'm super happy today to be joined by the one and only Efe Karakus, who is a software engineer as part of their AWS infrastructure as code team. Now, I know we're going to get into a bit about that, but yeah, Efe, you've been at Amazon and AWS for years. So yeah, what's your journey and what excites you about AWS today? I'm putting you on the spot, so sorry about that.
No, this is great. Yeah, so thanks, Julian. I'm Efe, so I'm a senior software engineer, like you said, on the AWS infrastructure as code team. And more specifically, I've been working for the past few years on the AWS Copilot CLI, and that's what we're going to talk about later down the line. I've been here for almost 8 years at this point, maybe a bit over 8 years. I started my journey on the Amazon Kindle side, and we used AWS services a lot. And early in that journey, I was actually using serverless offerings, and we were like one of the few teams that was pioneering serverless services within the org. And I just fell in love with it, and I needed to like learn how it worked and get closer to how everything is built. So I switched over to AWS. And yeah, ever since then, I've been kind of on a journey on trying to make serverless containerized applications easier on AWS.
Well, fantastic. Well, yeah, we're obviously going to be talking about a lot more about Copilot, but just looking back over the past week of AWS serverless, the past stream last week, which had Michael Gash and Jeff Oriokuya talking about integrating EventBridge and Kafka. This is a really interesting stream. If you are using Kafka in your on-prem environments, or you're running it on AWS or via MSK, which is managed streaming for Kafka, it's a really good way that you can integrate Kafka and EventBridge with a really good demo. So catch that and all other previous Serverless Office Hours episodes on Serverless Land, the YouTube channel. Just what's new in the world of step functions? What's new in the world of step functions? What's new in the world of serverless? Top of the list is step functions. And yeah, step functions just keeps knocking it out of the park. More native integrations. If you're unaware, step functions can connect to literally most of AWS SDK actions directly from a state machine. You don't need to run an instance, don't need to run even a Lambda function to do kind of things. And so it's added integration for 7 more services, including Amazon VPC Lattice. And VPC Lattice, we spoke recently on Serverless Office Hours. That's a way for to abstract the networking, and you can connect between Lambda and EC2 and container workloads, and just sort of fly over those VPCs in a really easy way, which is super useful. Of course, Copilot has been rolling a lot of announcements out. I'll do a link to some of their info so you can check that out. But Copilot announced a static site pattern to host single-page web applications. Yeah, Efe, do you want to just chat about that? What does that mean?
Yeah, sure. So Copilot was initially built for strictly on containerized applications, right? And one thing that we quickly realized is that, yes, people need, besides being able to launch containerized services, that might be their main application. They still need, a single page application alongside their API. They need some Lambda functions in there to be able to glue resources together, right? Make some transformations. And we've been adding newer patterns that helps complement the containerized architectures that Copilot already provides.
Oh, brilliant. Yeah, I always love that kind of story, because I think the whole, single page applications, storing it in your own web server, no need. Just, S3 is the biggest probably web server in the world. I can't cite that officially, but to me it seems as though it can be, and you would just tick a few boxes and set your security correctly. And yeah, running single page applications on S3 with CloudFront in front of it is a super good use case. And obviously, integrating it with container services would be great. And then just the next one down, Amazon S3, dual layer server-side encryption. So if you are in government or military, or you're just wanting to protect your family pictures, dual KMS based encryption for compliance workloads could be hopefully useful for you. And then just some recent AWS Compute blog posts. If you're a Ruby developer, Ruby 3.2 is out and ready for use for Lambda. So if you use that, the blog posts all about API gateway and custom domains using a reverse proxy, more step functions things. Have a look at the URL or via the QR code. Lots of information all about what's happening in the world of AWS serverless. But today we're talking AWS Copilot for serverless containers. And some people may be scratching their heads and thinking, hang on, there are other Copilots. What's AWS Copilot? Serverless and containers, surely that's an either or. Like, what are you people talking about? So yeah, I'm going to tee it up straight for Efe. But yeah, we've got lots to chat about because obviously we know people are using serverless and containers, and it's very much an and story rather than an or story. And many containers are serverless anyway. So Efe, over to you.
Oh, all right, thank you.
Sorry, before I remember, we are live, so send us your questions, send us your comments, let us know where you're from, let us know what your interests are. Because we're sort of combining serverless and containers today, we'd love to hear, how you found Serverless Office Hours and your sort of serverless experience coming from a container world. So yeah, please send us your questions and your comments via the chat, whichever platform you are listening on.
Yeah, and please feel free to interrupt me while I'm presenting or while I'm giving a demo of Copilot. It's totally okay. I'm happy to dive into the questions and you get deeper into the content. So
excellent.
I will quickly share my screen. Can you see my browser?
Yes, we can. Okay,
awesome. So my goal today is to give an overview of Copilot, the Copilot CLI. And like you said, it has nothing to do with AI. It's a command line interface that makes it super easy for developers to build, release, and operate production-ready containerized applications on AWS. And more specifically, the reason why we're on the Serverless Office Hour is that Copilot focuses on serverless containers, right? So we try to make it really easy for you to build applications on top of AWS App Runner or Amazon ECS on AWS Fargate. If you're not familiar with these services, I can give a quick overview. App Runner is our managed service offering for containerized web applications. So imagine you're building a service that's responding to HTTP requests, maybe something like a REST API. I would really encourage for you to look at App Runner because it provides super fast scaling based on the requests that you're receiving on your container. So as you're receiving requests, the service will automatically scale up your containers for you. And as the request lower, it will also scale in for you. And furthermore, you only pay for the active containers. So containers that are processing requests for you. On the other hand, Amazon ECS is a very general container orchestration service. So with ECS, you can give any type of container, any type of workload that you want. And the job of ECS will be, hey, here is a container image. Figure out for me how to run it on AWS. And ECS handles that for you. And the way it does that is that it places your containers into two types of different infrastructure. You could either run your containers on Amazon EC2 instances or AWS Fargate tasks. So for EC2 instances, these are virtual machines that AWS provides, and it's a really great choice when your application has particular hardware needs. Maybe you need something more network efficient or has a lot of memory. In those scenarios, or like burst instances, EC2 instances are a great choice. But one of the downsides of using EC2 instances is that you also get a lot of things that you have to manage on your own, right? Security patching. The other big sell for me for AWS Fargate, what I love about Fargate is that I don't need to think about the efficiency of my EC2 instances. But as you're placing containers on these instances, you need to make sure that you are using your hardware efficiently, that you're not wasting CPU and memory, and you're not paying more than what you need. With Fargate, Fargate essentially abstracts these EC2 instances and allows you to slice the instances to the appropriate size. So you only get to pay for what you really need, like however much CPU and memory you need. Does that make sense?
Yeah, that's a perfect roundup of it. I also like to sort of encourage people to understand the difference from a sort of, I suppose, layer in the stack from ECS and Fargate. That ECS is sort of your, I won't say orchestrator because that can confuse it with, container orchestrators like Kubernetes or EKS, but it is I suppose the control plane for your container environment, and then the worker nodes can either be EC2 or Fargate. And some people who come from a serverless perspective don't sort of get that because it's ECS on EC2 or ECS on Fargate. And in fact, you can't have Fargate without ECS, correct?
Correct.
So if you think of that as a sort of compute substrate, Fargate or EC2 being the compute substrate, and then Amazon ECS running on top of that. And then, app runners slightly to the side. And that's, this really simple way to build web applications, push your code up to GitHub and, or other code repositories, and app runner is just going to run it. And it's sort of another kind of abstraction. So,
yeah. And like for app runner, just on top of the whole like super fast scaling up and down, it really abstracts away a lot of infrastructure you would have to set up on your own for web applications, right? That is typically if you're building, for example, with Amazon ECS, you would have to create a VPC, you would have to create an application load balancer, the ECS service that's using Fargate tasks. So all of that is abstracted away by App Runner. You just kind of specify your port, your container image, and boom, you're good to go.
Excellent. Yeah, and Philip Koshi, thanks for joining us via YouTube. Is there a cold start problem with Fargate? Well, these are different kind of compute services, and Fargate can scale hugely. But you need to think of cold starts in a different way, I would think. So the problem I'm going to put in inverted commas because it's something you do need to manage a bit more compared to Lambda.
Yeah, definitely. Like I would say the team is always working on improving, the startup time for Fargate tasks. So I know that they made huge improvements, but I totally agree that this is something that you would have to think a lot more than compared to App Runner if you're using, web applications if you're deploying web applications, you would have to think a lot on the Fargate side. So that means that you might need to set up, lower thresholds for your alarms while scaling up and down based on number of requests or CPU or memory to make sure that you're scaling ahead of traffic. Okay, so if it sounds good, I'll switch over to Copilot again to illustrate why we really built and what are some interesting functionalities that Copilot provides to you by default. Copilot, we wanted Copilot to be an end-to-end CLI. So this is a CLI that's with you throughout the entire journey of your software delivery lifecycle. So that is, if you're trying to build containerized applications on AWS, Copilot provides infrastructure as code for you. This is kind of what you're seeing on the left-hand side in the screenshot that allows you to customize your ECS services or App Runner services. Then, besides being able to just deploy your infrastructure, we wanted to make it super easy for you to set up continuous delivery pipelines, right? So that you can deploy to multiple AWS accounts and regions, make sure that your changes flow through various stages, and you progressively get more and more confident that your changes are ready for production. And the last aspect of the Copilot CLI, after building and deploying, is around troubleshooting and operating, so day two operations. So we wanted to bake as much as possible ways of troubleshooting that your services are healthy, for you to be able to debug when an incident happens, to figure out what went wrong. And we added workflows around that. So
excellent. Thanks, Efe. It's just the screen didn't look just because the font size is small on the screen, but on the left-hand side, you've basically got a manifest YAML file, and that is going to build the infrastructure as code. I know we're going to look at that, but that just if people couldn't see that is basically a manifest file showing what infrastructure you're going to be deploying.
Yeah. And I'll after going through the homepage, I'll switch over to a demo, and we can get a better understanding of exactly what these manifest files look like. Just to give you
my eyes are probably bad because Versace Drib says size is good. So thank you very much for letting us know.
Cool. And just to give you an overview ahead of time, if you all are familiar with CloudFormation, right, that's our infrastructure as code service. All of Copilot manifests, they translate into CloudFormation templates. So at the end of the day, that you get, Copilot provisions all your infrastructure through AWS CloudFormation.
So there's an interesting distinction. I know we're going to get into it, how it actually does that. But if you're thinking, this is another tool, oh dear, this is another abstraction that's going to create. Yes, it's another abstraction, but ultimately it's just creating CloudFormation under the hood. And we know and use CloudFormation extensively. Anything that can make CloudFormation a little bit more intuitive to write for serverless applications, or in this case, containerized applications, is just going to make your life a little bit easier. But ultimately, it's nothing to be. It's not as new as you may think it is, because it's ultimately CloudFormation under the hood.
Yeah. So and just to piggyback on your point, is that we tried really hard to make it easy to get started with CloudFormation through these manifest files, and then slowly allow you to peel this like the onion, the different layers of CloudFormation. And then if you need to, you can customize the underlying CloudFormation templates. You can add your own CloudFormation templates, and Copilot will be able to deploy that. So these manifest files are really convenient ways for us to interact with containerized architectures. But if you need customization, and if you don't find a particular field that's surfaced in this manifest file, you're not blocked. You are always able to peel the layer of onion and dive into the CloudFormation template on your own. Okay, so to dive just slightly deeper onto these three different aspects that Copilot provides is that these manifest files for us, the input to Copilot, instead of being resources that you would define with your infrastructure as code templates, we took the approach of architecture as code. So, when we work right in the office, we tend to draw diagrams of like, hey, here's my application is composed of these various different types of architectures, such as an internet-facing service that's maybe accepting requests to a load balancer or API gateway. Then there will be another service that might be completely internal, or another one that's consuming events asynchronously from a queue. So the input to Copilot is architecture types. So these are some of the types that we provide within Copilot. And once you choose your architecture type, Copilot generates these manifest file, and then it ensures that the different architectures that are part of your application are all connected together. So for example, if I'm launching an internet-facing service that's a load balance web service, as well as a backend service, Copilot will ensure that the IAM roles, the security groups are all wired together properly to make sure that these two architectures that are part of the same applications are connected. Okay, the second aspect was the continuous delivery, being able to create pipelines. And today, Copilot supports AWS Copilot as your pipeline for delivering your application. It makes it also super easy for you to choose various AWS profiles and deploy your applications across many different AWS accounts and regions. And finally, we had different commands around testing your application and making sure it works. So I want to give a demo of this later, but yeah, so you can view your logs, for example, or get a shell that's connected to your Fargate task, or you can view the health of your services all through the CLI. Okay, cool. So I think I can switch over to a demo. And to illustrate the manifest files and what we're building today, I just built a very simple web application. So you can see that there's nothing fancy about it. It's not a very exciting application, but the capability, I think, is pretty cool. So if you can see my browser, you can see that there's a domain that's attached to my application, right? So I purchased this domain. I don't remember where exactly, but I delegated the management of the domain to Route 53. And then afterwards, into Copilot, I can give my domain, efekarakus.test.com, as an input, and I can specify any subdomains, multiple subdomains, and Copilot will do all the wiring necessary for you to get shop.efekarakus.test.com routes to my web application. So this is one aspect of the web application that we're building. Then I also added a different subdomain called admin. So this is another container that's running part of my application. And as you go to admin, you can see how many times this page got visited. So this is just me visiting the page a bunch of times. So this is what we're going to build, and everything that we're going to walk through in the demo will be within this context. Oh, and I forgot to mention a very important part is that the Copilot CLI is completely open source. It's available on GitHub. So github.com, AWS/Copilot.CLI. The team loves getting stargazers and new stars. So if you enjoy, this our conversation today, please give us a star. We'd really appreciate it. Okay, cool. So let me switch over to my IDE, and we can just get going with the demo.
If with Route 53, be honest with us, how many domains have you actually bought that you've got lots of ideas?
I have so many.
A new domain comes out, .cloud, .dev, the land grab with all these great ideas.
Yeah,
Yeah.
I had at least 4 in this one particular AWS account, and I'm not sure where everything else is.
The struggle is real. Yeah.
Okay, cool. So I think you can see my IDE.
Yes, we can.
And what I have over here that I've loaded up a sample application. So in the source, you can see that I have 2 different applications, 2 different services that I want to run, or actually we should say containers, right? Like you can see that there's a Docker file that is available, and these are all Node.js applications, admin and coffee shop. And I've deployed this with Copilot, like we saw earlier in the browser, we could load this application. So there's nothing fancy that's going on. It's just, you can point these Docker files and Copilot will be able to launch these applications for you. So to illustrate that, let's build a sample service together using Copilot. So within the terminal, once you install the Copilot CLI, which you can find in our documentation, you can just do brew install. You can type Copilot and you will get the help menu for the CLI. If you're familiar with the AWS SAM CLI, they also create these nice buckets of different types of commands that are available for you. So Copilot will have, we will provide many different commands, but under getting started, you could just write Copilot init, and then we'll have a wizard that will guide you through the different architectures and how you can build an application with Copilot. You can view the docs. If you don't want to use our getting started wizard, we have much more granular commands that are available under each one of these subcommands. So I can just run one-off task on Amazon ECS. I can create scheduled jobs directly with the job command, for example. The release subsection has commands around our continuous delivery pipelines or manual deployments. And finally, you can always expand the Copilot CLI on your own by dropping in CloudFormation templates. But we also provide some prepackaged CloudFormation templates. So we'll see how, for example, to create all these serverless databases or serverless storage services with Copilot, with the storage command, or you can add your own secrets to the application with the secret command. Okay. So to get started,
just before we go into the get started, you mentioned SAM. So SAM, lots of people are using SAM to build serverless applications. There are plenty of other frameworks, and if you're building a serverless application, use a framework. It's going to make your life much easier. How should people think about Copilot and how it complements yet is different? What's the sort of philosophy around Copilot for people who would understand SAM?
Yeah, this is a great question. So SAM provides 2 different products right under SAM. There's SAM Transform and then as well as the SAM CLI. So Copilot, the CLI itself actually contains both of these. So just like how you have SAM Transform to provide serverless resources, like abstractions to make it easy to use serverless resources, Copilot provides these manifest files. That's the equivalent, but for containerized workloads. And then just the SAM CLI is very much focused on local testing and iterating on your infrastructure and code together, right, with the local command and as well as the sync command. So Copilot doesn't have as much local testing capabilities, but because typically with containers, you can mostly run them locally with Docker run.
Yeah.
But we provide a lot of, just like SAM CLI, we provide a lot of functionality post-deployment. So you could do logs, you could do your status, things like that. Does that help?
Yeah, no, definitely. So people, so I know also on the first part of the SAM transform that there actually isn't a containers transform that Copilot is doing. It's actually it's a client-side transformation, and you feel, even though it's not a transform, and that is taking your manifest file and generating CloudFormation out of that, which then I suppose the CLI then pushes out that CloudFormation and runs a CloudFormation deploy. It's not quite the same as SAM is sending up your your SAM transform and sends that up to the SAM service, which then does the CloudFormation deploy.
Yeah, you captured it Perfectly correct.
Okay, and then the CLI just slightly different because Sam is doing serverless things, needs to focus on the local testing because it's it's Lambda integrations with API gateway and all other serverless services.
Yeah.
While on the Copilot side, you've got Docker Run, so that's very well, it's very well supported for everything, and so your CLI experience is more in terms of adding other additional services to your manifest file, and then some of the observability thing from logs and things.
Yeah, exactly.
Cool. And then, Philip has actually come with the question, is Copilot intended to work alongside CDK? So yeah, that's
a great question. Yeah, so just to go back to your point, I'll answer directly the CDK point. If you're familiar with the Cloud Development Kit, the CDK, Copilot's way of doing transformations is much more like the CDK, where you need the CDK toolkit. Like in the CDK world, you need the CDK toolkit to simplifies and do a client-side transformation and generate the CloudFormation template to deploy. Copilot was just like that. Yeah, the manifest file and then the CLI together to do the transformation and then deploy. And for the CDK, so we have a lot of customers that use Copilot and the CDK together. And the way that they tend to do it is that they use Copilot for their containerized workflows. So let me step back. First, they define most of their infrastructure with the CDK. So if you have VPCs, let's say serverless functions, maybe you have some EC2 applications, or RDS instances. Maybe they use the CDK to do that. But then when it comes to defining these containerized architectures, right, like load balance Fargate services, app runner services, maybe event processing Fargate services, they do that through Copilot. And the two can integrate together because you pass in your VPC ID and things like that, and Copilot can just deploy.
Yeah, no, I think that makes sense to me. I hope, Philip, that answered your question. If not, reply back to us. And I think in this sort of bigger container world, there's maybe a bit more of a separation between because containers are a loaded word. It means so many different things. It's a packaging format. It is a portability kind of thing. It's a standardization effect. It's a C groups and seccomp and all of that isolation kind of thing. So when one says containers, there are lots of different things we're talking about, which unfortunately get all stuck in the mix. But that's what the power of it as well. But my impression is with also the whole container ecosystem, and I come from an infrastructure background, that there's often in a lot of companies, maybe more of a separation of duties than maybe with Lambda, where you would have, some teams would look after your container infrastructure, and then your application developers would sort of inject code into that container, which is going to run. And so you are going to have teams who are going to look after VPC configs and other networking, and maybe your secrets and maybe your databases and all that connectivity, which is slightly more infrastructure. And then within that application code, and they may, then it's going to be brilliant to use Copilot, but then, sometimes within that application code, there are going to be other resources to spin up. And because that's more developer and code focused, that can be a bit more attractive to CDK. And that's a gross generalization, but I know some people think of the distinction like that.
Yeah, I think you captured it actually perfectly. Because containers allows you to package everything that you need to run your application along with all of its dependencies. We have many different types of enterprises and customers that use Copilot that have different organizational structures, right? So some are, like you said, there's a clear separation between the application developer that just creates the container image and hands it off. And there is an SRE team or a platform team that's deploying these containerized applications. On the other hand, you have maybe teams that are kind of more akin to serverless organizations, where they have embraced the DevOps movement and the engineers are doing it all, or the development team is doing it all, both running the infrastructure as well as writing the application code. Okay, cool. So I will switch over to getting started with Copilot. So what I'm going to run is the first getting started command to just illustrate the user experience that Copilot provides. So if I type Copilot in it, this is what I was mentioning earlier. The first thing that Copilot is going to ask you is, what type of architecture are you trying to launch? Do you want a service that's scaling based on the number of requests? Or do you want a service that's accepting traffic from the internet that you like to launch So yeah, a load balance web service that's behind a load balancer. Do you have a service that's completely private? Events to SQS, the ECS on Fargate. This is the newer service type that you mentioned, Julian, static site. So internet to a CloudFront distribution to an S3 bucket, or you can create scheduled jobs. So this is like containers that are triggered periodically. Okay, so to illustrate in this scenario, I'm just going to create a backend service type. Right? So this is going to be an internal service that's only accessible within the VPC. So if I choose backend, the next thing will be to give a name for your microservice that you're trying to launch, API in this scenario, and then I can enter a path that's local to my Docker file, or I can use a custom image. So for example, I can give a Docker Hub URL or a public ECR URL over here. But in this situation, I just want to use a local Docker file. So let me just make sure that I give the right path. So source, admin, or maybe coffee shop, and I can give the Docker file here. And Copilot will ensure that it builds this container image, pushes it to an ECR repository, and then generates the CloudFormation templates that use the container image. Okay, so you guys start seeing the different steps that Copilot is taking. The first thing that it does is that it creates a Copilot directory. I already had one, so it just skips that step really. And then it creates a manifest file. And this was the architecture as code file. That's for the API microservice. And you can see that we start creating change sets and start deploying infrastructure for you. So this will create, for example, an ECR container repository for the API service. And then it's going to start doing a deployment. Right now it's building the container image and then pushing it to ECR and then running, it's going to start executing a change set for your CloudFormation stack. So while this deployment is happening and we're pushing the image, let me lower the screen over here and we can start exploring what our manifest files look like. So here's for each microservice that's available in my application, I will have a separate directory under the Copilot directory. So this gets created automatically for you. You will have a manifest file for the API microservice, for example, as well as the coffee shop microservice. So this was the shop.efekarakus.test.com manifest file. I will take a look at this one instead because I think it's much more exciting than the backend service one. The first thing that you can see in the Copilot specification is that we have the name of the microservice as well as the type of the microservice. So this is the load balance web service type. And all the properties that's available in a manifest file is tailored to this architecture type. So we hide properties that have nothing to do of a load balance, of an application load balancer plus an ECS service. If that property is no longer relevant, right? So if you're trying to, I don't know what could be a good example off the top of my head, but if there is a field like a target group, I think the target group's port field or something like it is not really applicable. So we hide that from you. Like you don't have to worry about fields that are no longer relevant in CloudFormation or in the AWS API because Copilot ensures that we only provide the fields that make sense for this architecture type. I created here you can see that there are 3 different buckets of definitions that's part of the manifest. The first one is the container definition. So I'm saying that, hey, my main application image is under source coffee shop Docker file. The port that it exposes in the Docker file should be port 8080. And Copilot will actually parse the Docker file and fill that in for you. So in this scenario, I'm viewing it, but actually this was auto-generated by the Copilot CLI, this particular line. And then the same thing happens for a sidecar container. So I'm saying that this particular service should have 2 containers that are running side by side on the same Fargate task. And the Docker file path for this other sidecar called admin is under this particular path, and then it exposes port 9000. The next setting is the load balancer definition. So I have my application that was initialized with this particular domain, Then Copilot provides settings that are application load balancer related. So I can just give the domain, and Copilot will make sure that it's true CloudFormation, that it will create an ACM certificate. It will create custom resources to validate the certificate and add the A records into your hosted zone to make sure that the certificate is valid. And then it will create the application load balancer. Again, add A records to the Route 53 hosted zone to point to make sure that there's a record that points from the subdomain to the application load balancer. You have path settings in here. You can configure health checks. You can add additional rules, right? So I say that, hey, under the same load balancer, I want admin to point to another container that's not the main container, my sidecar container called admin. And finally, we have some task definition settings over here. So just like your basic CPU memory count, you can set up auto scaling features over here, very advanced ECS service connect, like ECS level settings as well.
Yeah, Philip nails it. Thanks for the comment again. This seems super intuitive. I love that, just setting an alias. You're not actually, in a way, it's that sort of extra level abstracted from CloudFormation that you're not even thinking in CloudFormation resources, but it's very natural for a container developer to think about, aliases and health checks and everything, rather than what does alias mean? Oh, well, that is a Route 53 record that needs an A record that needs to be added. So love the simplicity.
Yeah, thanks. So thank you so much, Philip. And I just wanted to showcase that, like, one of the, I wanted to reiterate that one of the common worries is that, hey, is this abstracting too much for me? Will I be able to get to the resources that I want? And if we go to this particular URL, so maybe I can switch over to the browser again really quick to just get an understanding of what's really available for me. Share screen. So if I go to this particular specification, you will be able to see all the different fields that's available under a load balance web service type. And again, these are just fields that are only relevant to this particular architecture, but we expose a lot of, there's a lot of configuration that's really available. I don't know if you can see my scroll bar on the right-hand side, but from creating network load balancers to like deployment configuration, or maybe you can set up your different architectures. So you can specify ARM, you want Fargate ARM task, auto scaling over here. So there is a lot of fields and a lot of power that's baked into the manifest file, but just getting started with the manifest is pretty minimal and easy to get going. And then if there is something that's not surfaced through this manifest file, you can actually access the CloudFormation template. You can add your own snippets of CloudFormation into it, or override the CloudFormation template. So I'm happy to demo that too if we have time afterwards.
And I suppose as this normal CloudFormation, you could reference other stacks. You can do all the CloudFormation stuff that you do already. Yeah.
So I will switch back to Visual Studio Code, and I want to showcase maybe let's see. Oh, here we go. Oh, the deployment is done. Okay, I wanted to showcase the UX during the deployment. Sadly, we don't get to see it. That's surprising. Normally, deployments take a lot longer. So, but I think one of the interesting aspects during the Copilot deploy command or the Copilot init command is that we don't display to you directly just like, hey, here is the logical ID or the resource type for this particular resource that we're deploying. We try to give this very nice like English text that explains why each resource exists and what is its purpose. So we say that, hey, we're creating a service discovery resource for your services to communicate with each other within a VPC. Or during a deployment of an ECS service, we don't just wait for the CloudFormation resource to go from to create complete. Instead, we also display ECS events. So you get to see your ECS deployment over here, saying that, hey, it went from desired count 0 to 1, and then the running went from 0 to 1. So all of these updates happen through the CLI, and you get this visual representation. Of course, if you use code pipeline, this is not relevant because the pipeline handles it for you. But while you're like while you're deploying to your like a development environment or a test environment, this can be really helpful for troubleshooting issues.
So just for example, then when it says that, oh, as you said, the service discovery for your services to communicate within the VPC, what then does that actually map to in terms of an actual AWS resource?
Yeah, so there will be a service discovery resource. So that will be the type is service discovery namespace, I believe. That's what it maps to. We'll have we try to name like the starting to be like, hey, CloudWatch log group, ECS service,
Yeah.
IAM role. So the initial like starting of the sentence is typically the resource type. Yeah.
So it is actually a service discovery. It's not abstracted enough that service discovery means it's actually something in parameter store or something else within Cloud Map. It's actually within service discovery. Yeah. So you're not lost. It makes sense, and you're halfway there.
Cool. Okay. Yeah. So this was the getting started experience with Copilot, and we just launched an API microservice, right? That's for a backend service, and we took a look at the manifest. I think the next steps that I can help showcase is let's see how to evolve this application. So again, if I type the Copilot command, you can see that we can go two different routes. I can maybe set up a continuous delivery pipeline for it to deploy across many different applications, or I can customize the architecture, add more CloudFormation into my application, onto my service. So let's do that first. So for example, let me type Copilot storage in it, and you can see some of the options that we provide. So these are default CloudFormation templates that's baked into the CLI. So you can set up like an Aura serverless, like a SQL database, or with Aura serverless v2. You can store objects into an S3 bucket, or you can have your nice NoSQL database with DynamoDB. So whichever one that we want, we can. Let me just pick Aura serverless because that's always exciting. And it's like a heavy resource, right? There's a lot of CloudFormation that goes into it. And I can choose which workload I want to associate with the storage. So by default, Copilot tries to provide the architecture pattern of a single microservice accessing a single database. That's like our default setup, but again, we try to be opinionated but not prescriptive. So if you want to have multiple services accessing the same database, you're welcome to just modify the CloudFormation template, and you'll be able to achieve that. But our default template will just be for accessing a single microservice should access the one database. So here, for example, I choose the coffee shop microservice. I can just choose the default, and then I'll say, yes, the storage should be created at the same time. Yep, I can choose this. And then I can choose MySQL or Postgres, whichever one I want. I'm a fan of Postgres. And let's say that I want to name my table like users. Okay, cool. So you can see that the output over here will be a CloudFormation template, and the CLI tells me even how I can access the secret that will be associated with the database. So for example, we give a JavaScript snippet over here on how to we'll inject the secrets as environment variable, right? That will contain the username, host, database name, password, port, everything that you need to connect to the serverless or a serverless cluster. We'll inject it as an environment variable. So for example, if I navigate back to the file directory over here let me close anything that's not relevant so it's easier to see for us. Under coffee shop, we have a new directory now called add-ons. And under add-ons, we have a CloudFormation template. So this is just regular old CloudFormation with YAML. So we try to make it as human readable as possible. We add our own little comments over here. And you can see the CloudFormation template that gets generated. By default, everything will be wired up, the security groups and all that, such that your service can access the database. And then let's say that, let me open up the terminal again. Once you created this file and you made your modifications, if you want to modify anything, I can go and run the follow-up command that we listed over here, right? Copilot deploy, and that will start creating the database for me. So that's the basic user experience that we can see with the Copilot CLI in terms of deployments. Okay, and how to extend it. The other aspect that I can help show in terms of extension, so we just saw how to create a CloudFormation template that that adds additional infrastructure. But if I wanted to override anything that Copilot provides, we will have, so let me dive deeper into some of these subcommands. So for example, if I type Copilot service, Copilot service, so these are all the commands related to services on interacting with Copilot services. So you can see there is a lot that's available in there, like listing all my existing services that are deployed. I can delete my infrastructure or my application. But one of the commands that we provide, and maybe this is great. I can type like Copilot service package, and that should give me for the coffee shop service. So that will spit out the CloudFormation template that's used for the Copilot, that where the manifest file gets translated into this CloudFormation template. So you can read it on your own, get an understanding of what's going to be deployed before a deployment. Julian, did you have a question? Sorry.
No, that's good. Sorry, I was just a distraction on my end.
That's all good. And then what I wanted to do was, show override. So here, the override command allows you to override the CloudFormation template of a service. So if there is any particular field that you don't like, that you would like to change when moving forward with the Copilot CLI, I can type Copilot service override. Again, I can choose the microservice that I want to override in the CloudFormation template. And then we provide two different flavors of overrides. You can either override with the Cloud Development Kit. So if you prefer the programming language to change the CloudFormation template, or if you like to stick with YAML and actually see you don't want to use any higher level abstractions to actually modify your template, right? I can provide a YAML patch. So just to illustrate over here, let me go back to the files, and just like how we had an add-ons directory, now we'll have an overrides directory, and you can add. There's a README file in here and some documentation. I just wanted to give you an overview of what's capable with the CLI. That you can say, hey, I want to remove like the task role that was created with this, with the Copilot CLI, and that's possible through overrides.
So I suppose that I sort of like that approach that you, in a way, you're not messing as much with your base deploy, and it gets so out of sync that you can't sort of run the Copilot in it again. But you've got this way of sort of layering on changes that, in a way, it's far easier to see how you've diverged from the original. And I think with that would probably make it a little bit more portable, because you can understand what changes you've made to your app.
Yeah, we wanted to provide, from our understanding with customers, from talking to customers, is that they were seeking for a progressive developer experience where the manifest file, for most customers, it was just fine, and you really don't need like overrides or anything like it. But there is always there will be always a situation where, hey, I need to tweak something, and in those scenarios, they don't want to, get rid of Copilot and then have to manage this large CloudFormation template. They were just looking to make some small tweaks into an existing template, and that's why we provided the smaller ways of doing like JSON patch or a YAML patch on top of the CloudFormation template. Okay, so actually, this can stay. This is totally fine. Let's go back to the terminal, and I can showcase some other functionality. So one of my favorite aspects of the CLI is that we bake in troubleshooting commands into the CLI. So for example, I can type Copilot service status, and then it's going to tell me, hey, you have an API service and a coffee shop service that I deploy to test environments. I'll choose coffee shop over here, and then it will show me like my task summary. Hey, you have 1 out of 1 tasks that are running. They pass HTTP health checks as well as container health checks. Everything looks good. So you can use the status command, for example, to view the health of your service. If you have define your own custom CloudWatch alarms with CloudFormation under the add-ons directory. All your CloudWatch alarms will be displayed over here. So you can view the status of your alarms and see if there's anything that's in alert mode, in alert status. Let me see. I think we can do Copilot service logs, and then you can do -- follow to be able to tail the logs for your service. I don't think I actually log anything in my Node.js application, so this is not going to print anything. But this will be the way of like tailing logs and being able to filter on logs. Then there is, I think my favorite is actually Copilot service exec. So this allows me to tunnel into my Fargate task and actually start running commands from the point of view of the task. So I can, for example, I just connected to my Fargate task with this particular ID. I think I said that the port number was 8080, so I can run curl over here. You see that I get a response saying, "Welcome to Efe's Coffee Shop," or like this task should be connected to a RDS database. Maybe I can start running some commands against the database by connecting to the container. And yeah, so
wow, this is super simple. So I mean, you're SSHing into your container, but under the hood, how are you actually doing that? Is it via Systems Manager or via?
Yeah, that's exactly it. So ECS,
cool.
The Elastic Container Service, has a feature called ECS exec. Sorry, I just blanked out for a second, but that is literally, it's the name of the command. And they set up the Systems Manager agent for you, the SSM agents on the Fargate task for you. And what Copilot does under the hood is that let me just showcase the manifest really quick. In the manifest, we by default write exec true over here. You can set this default if you don't want the agent running. But so exec true allows you to have the agent running on part of the task. And then with Copilot service exec, you don't have to install a separate. Normally, you would have to install the SSM plugin CLI to be able to connect to the Fargate task. Copilot manages that under the hood, so you don't have to install another CLI to actually connect to the container.
Wow,
does that
love
help?
it. Yeah. That just looks so cool.
Yeah, and I don't think we had time, but like there's also I can stop here but we also have the Copilot pipeline command to set up continuous delivery pipelines. And this allows me to, if I type Copilot pipeline in it, I don't think I'm connected to a Git repository yet. So there's no Git repository available. So it errors out here. But let's say that you have a GitHub repository, then just like how we showcased Copilot in it and had a wizard with guiding you through how to create your architecture, would guide you through creating a code pipeline.
And then within that pipeline, you could run, you could run whatever tests you need and, progress that.
Exactly. Yeah. So like I'll switch over to docs again just to showcase.
And I did see earlier while you bringing that up that, there was an option to add a test environment. So is that then, a separate set of ECS and Fargate tasks for a test environment compared to a production environment? And then that also would then translate into different pipelines that it would have, different stages.
Yeah, that's exactly right. So the Copilot, sorry, I didn't showcase that, but there is a Copilot env init command, and env stands for environment. So that allows you to create the test environments and production environments. Actually are not at all different from each other. It's just the name that you give for the particular environment. But you could say that, hey, my production environment is in US East 1. My test environment is closer to my developers in US West 2. And then each environment will have its own manifest file, right? There's a lot of settings here. So this will be, the environment will contain resources that are shared across your services. So this is, for example, things like your VPC or your application load balancer settings. So you can configure, so for example, in your test environment, you can be maybe a bit more frugal and place your task in public subnets and not with NAT gateways. But in production, you might want NAT gateways. And things like that.
Or you have smaller tasks because they're going to be in development, or you're going to have, I think multiple developers in a single account are going to have their tasks within a shared VPC, but production is going to be a separate. Yeah, I mean, all the kind of considerations you could have.
Yeah, and then like pipeline, when you run pipeline in it, like everything, Copilot just interacts with manifest files, and we generate manifest files for you to edit. So everything is done through infrastructure as code. And you can see for a pipeline, you can say, hey, in this scenario, deploy to a test environment first, run these commands, such as my integration test to make sure that everything is good, and then deploy to prod, add a manual approval button. Again, this simplifies the template for AWS code pipeline significantly.
Excellent. You had one before when we were setting up, when we were preparing for this, you were talking about there was a difference with Copilot, that it wasn't quite infrastructure as code, but you had another term which has slipped out of my brain.
Yeah, architecture as code.
As architecture as code. There we go. Yeah. And I think when I was talking earlier about that sort of slight separation of the architecture / infrastructure and the application kind of things, yeah, I like that. I like that distinction of architecture as code.
Yeah, so and you can see like the different architectures that we provide over here. In the documentations, I think under concepts, if I go under services, we'll have like a detailed overview of what each architecture really looks like and give an explanation of what they are. In the docs, you can see all the fields that are available in the manifest file under the manifest section. Under developing, we have guides on exactly like setting up observability, publish, subscribe, right? So setting up SNS topics and SQS queues, adding secrets, communicating between your services. So we try to provide guides for you to be able to just get going and focus on your application code rather than fight your infrastructure. And yeah, well, I hope this was useful.
If it was super useful for me, thank you. I've learned a lot. I hope also all the other people live on the stream, thanks for joining us, and the people who are watching this after their effect have got opening up a new world to see how we can manage containers on AWS, specifically with ECS and Fargate, and also via App Runner. Yeah, super useful. I can see the care and attention that has been put into the Copilot CLI, really thinking it from a developer workflow perspective, abstracting what needs to be abstracted, but giving you the sort of wherewithal to be able to dive deep if you need to get into the individual cloud formation, and, really good explanation. Thank you.
Awesome. Thanks. And just to end, sorry, again, you can find us all on GitHub. Our team is super active on GitHub, on Aspiring. You can cut us. You can see just like 2 hours ago, 8 hours ago, 15 hours ago, folks have been asking us questions, and my teammate, Adi over here, has been replying to them. And yeah, please cut us issues. You can create pull requests for us. We would love that. You can also create discussions. And finally, instead of creating GitHub issues, if you find that too intimidating, or maybe you're just hesitating on it, feel free to chat with us on GitHub. So on the README, you can find a link to our chat, and this is live chat directly with the engineers that are building the tool, and we try to answer your questions.
Excellent. Well, thank you very much. Seems lots you can do, and obviously we'd send us your use cases, send us information that we can make it more successful for you. Efe, thank you very much. Just before we quickly say goodbye, next up we've got an interesting one. We're actually talking serverless high performance modeling, and this is HPC in the cloud. Basically, we've got a partner in the UK called 4Theorem. They've written so many tools and are super brilliant on this serverless high performance modeling, how you can scale out Lambda, and you can also scale out Fargate to do for a reinsurance company who was able to reduce their modeling from, I think, 10 hours down to 1 hour. So yes, catch us next week. That's going to be super useful. But yeah, Efe, thanks so much for your time today. It's been a pleasure to learn lots about Copilot, and thanks for bringing a really great demo and being super good with the questions. So thank you very much. And we'll be back. We'll be back. Thank you. We'll be back same place, same time next week for another edition of Serverless Office Hours, and catch up with us on serverlessland.com for all other interesting information about serverless on